Okay, so last lesson we did finding the inverse of a 2 by 2 matrix. Okay, so I give you just as a refresher. Okay, if we said that if A was matrix A, B, C, D, then A inverse is equal to 1 over AD minus BC times, so the 1 over the determinant, right? We call this the determinant. We're going to talk about this next chapter, times the adjoint matrix, which also we're going to talk next chapter. So DA, so you interchange A and D, and you change the signs of B and C. So minus B here, minus C here. This is how you find the inverse of a 2 by 2 matrix. Okay, so now I'm going to show you how to find the inverse of a 3 by 3, 4 by 4, any size matrix. Okay, so to do that, there is what we call an inversion algorithm. So let's call it the inversion algorithm. And what this is, it's a bunch of steps that we're going to follow to take a matrix and find its inverse. Okay, so the best way is to do an example. So for example, find the inverse of, so I need to leave some space because there's a bunch of steps here. So let's say A equals, okay, so I wrote down an example, 517, 312, 103. Okay, just if you could see. Okay, it's clear. Okay, so that's my question. I want to find the inverse of this matrix, provided, of course, it exists. Let's say it exists. We'll see. If it doesn't exist, we'll figure it out. But it does exist in this case. I will give you special cases soon. Okay, so solution. So here's the idea. Here's how the algorithm works. So you write the matrix 5, 1, 7, 3, 1, 2, 1, 0, 3, and right next to it, you write the identity 1, 0, 0, 0, 1, 0, 0, 0, 1, and I create a new big 3 by 6 matrix. Okay, so basically here I have matrix A, and here I have matrix I. Okay. That's how we start. Take A, put I next to it. Then I'm going to do a bunch of elementary row operations, and I'm going to transform this matrix into a reduced row echelon form, which we know how to do. Okay, so let's start doing some steps. So I'm just going to change something here. When I'm going to do a transformation from here to the next step here, I'm going to write the operation here in the middle of the two matrices. Okay, same thing. I'm just going to write it here now because it's going to help us when we do what we call elementary matrices very soon. Okay, the first thing I'm going to do is, of course, I need a leading one on top. So I'm going to interchange row 1 and row 3. Okay, so I'm going to write this down here. So row 3, I'm going to put in row 1, and here, row 1, I'm going to put in row 3. This is my first step. Let's do it together. So first row, third row now goes in row 1. So 1, 0, 3, and 0, 0, 1. Okay, so the whole thing, whatever I do on the left, I do on the right, everything. It's just like one matrix. Second row did not change. 3, 1, 2, 0, 1, 0. And the third row now becomes row 1. So 5, 1, 7, 1, 0, 0. Okay, this is my first step. Second step, of course, I need zeros here and here, where the 3 and where the 5 are. So I'm going to do row 2 minus 3, row 1. And here I will do row 3 minus 5, row 1. Okay, so I believe we're good at this by now. So let's go. Row 1 does not change. So 1, 0, 3, 0, 0, 1. And now row 2 minus 3, row 1 is 0, 1, 2 minus 9 is negative 7. And the, row 2 here minus 3, row 1 is 0, 1, and negative 3, right? 0 minus 3, row 1, I get a negative 3. Now row 3 minus 5, row 1. So that's 0. This minus 5 times that is 1. 7 minus 15 is negative 8. And now 1 minus 0 is 1. 0 and 0 minus 5 is negative 5. Okay, so of course, if you want, you could just pause the video, try it until it becomes reduced to echelon form, and then validate with what I get. It should be, that's what I would have done. Okay, let's keep going. So I need a 0 here now. So row 3 minus row 2. Okay, let's do it. So I will, how am I going to manage the space here? Okay, let's do it here. And worst case, I will continue up thereafter. So at this point, I will do, so my row 1 does not change for now. 1, 0, 3, 0, 0, 1. And here I will do, second row also doesn't change, actually. 0, 1, negative 7, 0, 1, negative 3. And now row 3 is, I will do row 3 minus row 2. I get 0, 0, negative 8 plus 7 is negative 1, 1, negative 1, negative 5 plus 3 is negative 2. Okay, and now I need to get a 0 where the 3 is, a 0 where the negative 7 is, and a 1 where the negative 1 is. That would turn this into a reduced echelon form. 0, 1, 0 is perfect for me. Done, and 1, 0, 0 already good. So the first two columns are good. Okay, so I will do in one step, I will do row 1 plus 3, row 3. Then row 2 minus 7, row 3. And then I will do negative row 3. So these are the 3 operations I'm doing now. Okay, of course, when we're going to use determinants, we're going to do this with determinants. We're going to do step by step, and we're going to do elementary matrices also. We're going to step by step. I won't do 2 at a time, I'll do 1 at a time. But for here, it doesn't matter. I just want to save time. So row 1 plus 3, row 3. So let's go. 1 plus 0. Okay, so this is 1. 0 plus 0 is 0. And 3 minus 3 is 0. Then 0 plus 3, that's 3. 0 minus 3 is negative 3. And 1 minus 6 is negative 5. Then row 2 minus 7, row 3, 0, 1, 0, negative 7, 8, negative 3 plus 14 is 11. And the last row, I'm just timesing it by -1. So 0, 0, 1, -1, 1, and 2. And I'm done. Okay. Perfect. Okay. So what just happened here? I started with A, I got I. I finished here with I. And this now, this matrix on the right, it changed from I to A inverse. So I just found A inverse. Amazing, okay? This is the step to find the inverse. So as you transform A into the identity, by the same steps, the identity turns into A inverse. Okay, that's what happens. You will understand this more when we're going to do elementary matrices. Okay, so let's verify that we are correct. Okay, so I'm going to do here. So I'm going to write right here. Then A inverse is equal to, so what did I find? 3, -3, -5, -7, 8, 11, -1, 1, 2. Okay, so verification. Okay, so if you have time, of course, on the test, you should verify that your answer is correct. So A times A inverse, or A inverse times A. This case it always doesn't matter. So A is 517, 312,103 times what we found as A inverse, 3, -3, -5, -7, 8, 11, -1, 1, 2, and see what we get here. Okay, so 15 minus 7 is 8, 8 minus 7 is 1. Then -15 plus 8 is -7 plus 7 is 0. And then -25 plus 11 is -14. Plus 14 is 0. So far, so good. Now here, 9 minus 7 is 2, minus 2 is 0. -9 plus 8 is -1 plus 2 is 1. -15 plus 11 is -4 plus 4 is 0. Oh, I think we're on the right track. And then 3 minus 3 is 0. -3 plus 3 is 0. And -5 plus 6 is 1. There you go. Perfect. Okay, so if you do this on your test, you could even check. You're so sure that it's right, and you could sleep well at night. Okay, so that's it. That's all I wanted to show you in today's lesson. Okay, what's left is, after that, is just the algebraic properties of the matrix inverse. Okay, so of course, what happens if we have A plus B and we find the inverse of that, or A times B, the inverse of that, or A transpose inverse. All these are algebraic properties. This I will do with you in class. Okay, so for now, I just want you to understand this algorithm. I'll give you an example to try on your own. Okay, and if you're able to do this example plus the example that I'm going to give you now, I think you understand. Okay, there's nothing complicated. Okay, so let's try. So exercise here, you'll try it on your own. And I'm going to leave you with this. So find A inverse given A equals, so I prepared an example. Let me just pull it up. 312, 433, 423. Okay, I want you to find the inverse of this. Okay, and I'm going to write down the answer for you. The answer is, you could verify, that you got it right, even though you don't need me for this because you could verify the way I did it, but at least you know what to aim for. So 3, 1, -3, 0, 1, -1, and -4, -2, 5 is the answer. Okay, that's it. This is what the inversion algorithm is all about. So this is all the technical part. The last two classes, the ones I gave you on video, are very technical, finding the inverse of a matrix. And after that, we're going to go into a bit more abstract stuff and more proofs and more algebra.